Alright, so what we're testing today is Amphora, a new water company I've been using. I don't know, I'd say the last 3 months I've drank their water solely. I feel excellent, but anyways, what this is about is they have new drops. I travel a lot. I asked them, I was like, I can't really bring your bottle on the plane. Do you have something like concentrate? Because right now Amphora is, I think, only online in their local area, but anyways, I can't buy it at the store yet. So, I have a meter. Before I am testing this, I basically calibrated everything. So all these basically buffer solutions, calibration solutions, you want to use these. If you want a very accurate test, you want to almost do it after almost like every 10 measurements if you want to be highly accurate. Some people buy these, this meter, like an ORT meter, pH meter again. For me, those keep falling out of calibration, so some days after a month I just randomly bring them when I travel, and I'd kind of check out Voss, Dasani, Fiji, compared to Amphora just for fun. So what we're going to be testing is tap water. My original reading was 394 millivolts after 5 minutes. So we're going to put the meter in, and it says to add 8 drops. So sorry it's out of video. I'm doing this with my iPhone because I don't really have a professional camera. Alright, 1, 2, 3, 4, 5, 6, 7, and 8. Alright, put the dropper back. Comes in like a black thing. Stir this up. Alright, let's see what happens to tap water. This looks like it may be a long process. I'm gonna stop the video and then cut back. I'm gonna give this 5 minutes, just so you don't have to sit here for 5 minutes, and we'll see what the reading is. This meter takes a long time to stabilize, so I think 5 minutes will be good. I'll cut back when it's done. Thank you. Alright, I'm back. It's been right around 4 minutes, 30 seconds. We'll give this 30 more seconds and see what it drops to. Again, the original reading, we were at 394 millivolts before. We're already at 41 millivolts, which is a very large drop. Alright, that's 30 seconds. Let's call that 40. So I'll write that down, and then next we'll go to Dasani. Alright, we're gonna go to Dasani. When you're testing this, you want to take whatever measurement equipment you're using. I have distilled water that I basically change out after every wash, just because sometimes cross-contamination can happen. So if you're doing tests like this, you'll hear it in the background, but basically I have a big cup of water. And I just wash the electrode. Kind of shake it off. So now it's all clean. I'll put that in there, just so there's no air bubbles on the sensor. I'll get the little dropper going. Okay, so we're gonna add 8 to this. 1, 2, 3, 4, 5, 6, 7, and 8. So drop her back. Give it a stir. Also, why you want to stir it is you don't want an air bubble on the electrode. I've been testing kind of water for a bit, just because I like to know what goes in my body, but I've had weird readings when there's air bubbles on the electrode, so make sure to swirl it if you are going to test it. Alright, again I'll come back in 5 minutes, and then we'll see the reading. Alright, so 5 minutes is up in 10 seconds. Alright, so say we're at 28, and 360 was where we started at. So let me write that. RP, we're at 28 millivolts, which again, from 360 to 28 is a huge difference. When I started to drink, first I had a Kangen machine. That didn't go too well, but the Kangen machine definitely helped me realize ORP is a huge part of good water. Because basically what happens in your body is your whole body's kind of electric. So the millivolt swing, it takes your body 360 millivolts on the opposite side to actually process this water. When it drops this far, your body doesn't have to work as hard. I know Amphora is a negative ORP, they're drinking water, but just bringing it down to this changes this water to actually a quite good water. Dasani I'm sometimes stuck with at certain airports and things of that nature. That's why I'm testing it. It's kind of Dasani and Voss. I've used a lot. So next we'll do Voss. That was the reading first, so let me set up the tripod, clean the electrode, see if we can do a seamless one with this. Again, just clean this with distilled water. You can hear it in the background. Just gonna swirl it. Put that back in. That's coming back up to around 292. Let me get the drops. Again, we'll do 8 drops as they say on the label. It's nice how it's all glass and black. Alright. So, that. And again, I have 8 ounces in each of these. It says that it changes 8 ounces of water, so just following the label and seeing kind of what effect on what water happens. So 1, 2, 3, 5, 6, 7, and 8. I'm guessing you can do like 16 drops if you want to really change the water, but I'm just going to follow the instructions, so this may help someone else. So we'll stir that up. Try to get this unseen. Alright. Wow, Voss really likes these drops, it looks like. Already at 20. So again, I'll stop, or I'll come back filming after 5 minutes with a few seconds left just so we can both see it equalize. So I will be back. Alright, got about 4 seconds left. I was eating popcorn. Kind of hovering at -5, -6, -4. It keeps jumping. Okay, time's up right now. So we're at 292 millivolts. So, a weird tripod. Let's put that down. Next we'll do the pH. And what I'll do is change this water out and use the last of the Dasani and Voss. I got a 16-ounce Voss and 20-ounce Dasani. And then the tap water is really easy. Alright, so we're at -6 millivolts. So Voss actually went negative. So this negative, from when I had a Kangen and all that stuff, once I dropped the ORP, you can on the machine, you can drop it. What I noticed was almost like an energetic coffee type feel, but it's from water. I've had way better results with Amphora, which is, I think they're -80 on their normal water, versus the Kangen. The Kangen, I'm a scientist and engineer. The Kangen to me feels very electronic. It's not like nature at all. So basically electrodes kind of change the water. But just going negative alone, huge benefit, huge benefit. So we went from 292 to -6. So I'm going to clean out all my glassware with distilled water, dry it, let it dry, and then I will be back and we'll test pH on all three. So we'll just do a little thing, what we've done so far. So tap water, after 8 drops, dropped to 40 millivolts. Dasani 360 millivolts to 28. These are massive drops. And then Voss, the last one we did, is 292 to -6. So it actually changed the water to a negative ORP with 8 drops, which is kind of blows my mind. All right, so I'll be back and we'll test pH. All right, so this one we're gonna test the pH. The meter that I have, again, is the 99720. Has interchangeable tips. Had it certified, calibrated. It's legit. I also have all the buffer solutions. I also have other meters that I just kind of test for redundancy. So we're gonna put a new basically sensor on it. You always want to keep these wet. There's solution you can get, this stuff, soaking solution. It keeps everything proper. So we're gonna unscrew that, put this on. It goes like that. And twist that on. And power on. Make sure it says pH. It already reads the sensor, but there we go. It's measuring the ambient temperature as well. Alright, so we'll put that in here. Bring that closer. Let me get the dropper, just get the air out of the sensor. So again, we're around 8:15, but I'll give it 5 minutes just to equalize. I'll also do a temperature recording because pH also varies on temperature. So not many people know that. So when you do these buffer solutions, you want to basically, you need to know a little more than just the pH number. The temperature is also important. So this is kind of the buffer solution I use. Don't drink this stuff, not good for you. So I'll come back in around 4 something minutes or less. I have a timer going, so I'll be back with about 10 seconds on the clock, and we'll take a reading, and then we'll do the 8 drops and see what happens. Alright, so we're pretty much equalized. We're at a pH of 8.38 for my tap water at 22.4 degrees Celsius. So let me write that down. So we're at 8.38, 8.38 at 22.4 degrees Celsius. Alright, so now we'll do the 8 drops. The dropper. Alright. 1, 2, 3, 4, 5, 6, 7, 8. Give it a swirl. Get the air out. Gonna dip it. Alright. I'll come back after 5 minutes again. I have a timer going. So I'll be back with the stabilized reading. Alright, so we're back. Let's see here. So, bring this in. So before we were at 8.38 at 22.4. I accidentally just moved that, so that changed the reading just a tad. We actually dropped to 8.36. It hit 5 and it just went back to 6. Oh, now it's going to 7. We'll see what happens. Alright, 5 minutes is up right now. So it actually dropped 0.01 pH wise, which is very interesting. I'd like to know how they actually make this, because that's interesting. Alright, so we'll write that down. pH. Oops. So, alright, it's still at 8.36. 8.36. Did our water temperature change? No, it did not. 22 degrees Celsius. So, interestingly enough, the tap water went down 0.02. So it's almost like the drops balance the water, is my guess. Next we'll go to Dasani. I think they have a pretty acidic pH, but I'll be back. Let me clean my sensor with distilled, and then we'll pour Dasani in this guy and get this one going. Alright, we'll do Dasani, 20 ounce. Alright, that's empty now. Let me get my electrode clean. Shake it out. Alright. Put that there. Initial reading right away, 6 something. So way different than my tap. My tap was 8.38. So again, we'll give this 5 minutes and I'll come back when we got some seconds on the clock. Alright, and we're back. Got 5 seconds on the clock for this one. And alright, so we're at 6.24. Oop, 6.23 pH at 22.1 degrees. So 6.23 at, oops, sorry, I'm not getting this on there. 22.2 degrees Celsius. Alright. Now, let me clean this. Get that going. Alright. Let me get the drops, and we'll see. I leave it in there just to see in real time the actual change. So, 1, 2, 3, 4, 5, 6, 7, 8. If I get a drop wrong, I'm sorry. I'm trying to film and hold the dropper and shake this. Alright. I'll let that stir. Let that read. So already it's climbing up. Again, I'll be back in 5 minutes. We'll see what it stabilizes at. Alright, so Dasani is equalized. Got 5 seconds. 5, 4, 3, 2, 1. It's at 8.67. I think our original was 6.23. So let's mark that down. Oop, threw my pen over there. Alright, so put that over there. pH, and that is 8.67 at 22.3 degrees centigrade. So we went from, oops, sorry about that, looking at the paper, not the camera. pH 6.23 to 8.67. So again, completely changing the water. Next up will be Voss. Those are ORP readings, so let me set this up, clean my sensor, and we'll do the pH and get that going. What a weird tripod. There we go. Alright, I'll be back. I have to... Oh, I got it. Alright, so let's get that going. Let me clean my sensor again. Alright. Looks like a 6.57. Let me change this scene. Hold on 1 second. Alright, so got the sensor on. Initial reading is 6.96, but again, 5 minutes. I'll be back with a few seconds on the clock. We'll see where it goes. Alright, so we are equalized. Forgot 5 seconds. 5, 4, 3, 2, 1. So we're at 6.97. Write that down. 6.97 at 22.5 degrees Celsius. So here's that. I'm gonna add the drops now. Put my pen down. Get the vial. 1, 2, 3, 4, 5, 6, 7, 8. Alright. I'll stir this up. This one's kind of hard to stir because it's not tall. pH is already going up, but I'll come back and see what it equalizes at. Alright, kind of spilled all over stirring this one. I got 5 seconds. I'm not going to move it, I'm just going to move this. So we're at 8.05 pH, 8.04. So let me mark that down here. pH. Oh. Camera almost ate it. Or my iPhone, really. Alright, so we're at 8.04 at 22.5 degrees Celsius. So again, looks like these drops basically fix the water, which is quite wild. Again, so we're at 6.97 and again went to 8.04. Let's just go through the readings. The Voss one just spilled on everywhere. I can test TDS, conductivity, all that stuff later, but Let's just go around. So tap went from 8.38 to 8.36. The ORP dropped, looks like, if my math is correct, 354 millivolts, which is huge. We have pH 6.23. Dasani after the drops, that's a 6. 8.67 at 22.3 degrees Celsius. And the ORP went to 28 millivolts. The last one I spilled all over because it's hard to stir the Pyrex is, let's see, sorry if that, you can kind of, there we go. 6.97, 22.5 Celsius before. The ORP was 292. The pH after was 8.04 at 22 Celsius, or 22.5 exactly. And ORP went negative on this one. So it seems like, if anything, the closest you can get beyond Amphora would be to buy Voss, or, I mean, I'll keep testing and see what one's the best, but what I'm trying to do is get closest to the water. So for travel, it looks like I may stick with Voss. The one I will be testing soon will be Smart Water. Kind of interested to see what that does. But again, this was for the drops that Amphora sells now for kind of us travelers or people on the go that can't really bring Amphora everywhere until it's everywhere. Thanks for watching. If you have any critiques or anything on my testing processes, I'm pretty good at testing, but if you have suggestions, I'm wide open to them. I do have a lot of sensors and measuring systems, so if you want to check out anything other than pH or ORP, that's kind of really important to me after my research, let me know. I can add like TDS. What other thing does my sensor have? Conductivity. I think that's it. But yeah, thank you guys for watching. If you're a water nerd like me, hopefully I did all the stuff for you to actually see this is not a fake product, but actually does something to the water. I don't really understand water science too well, but I can at least measure it and make an informed decision. So again, thanks guys. Talk to you.